Okay, final hard question of Chapter 5, so 5H4 of the second edition of Statistical Rethinking. Make sure that you have installed and loaded the Rethinking library with these first two code blocks up here at the top of the Colab sheet. And here we go. Okay, so this one, depending on your initial decisions, can get you into a few conundrums, and that's what has happened to me, but that's okay. I will walk you through my thought process, and not that my thought process is pristine or perfect, but it's a thought process and it may give you ideas in thinking through your own. Okay, so the idea here is that we are going back to the waffle divorce data set that we saw earlier, and we are, earlier in the chapter we were modeling divorce, D, based on other predictor variables, marriage rate, M, and median age of marriage, A. And now we're asked to include an additional predictor variable or explanatory variable, S, for Southerness, which is just an indicator variable that is 1 if that state is in the southern United States and 0 otherwise. Okay. So the idea is that we're going to try to determine how Southerness relates to these other variables. Okay. Now, so there's a lot of potential answers here, and so I will walk you through mine, but the important thing here is not to get the right relationship down. It is to make a reasonable hypothesis and then set about testing that hypothesis with the available data. Okay, so I'm going to start by presenting my DAG. Okay, this is how I think these variables are related causally. Earlier in the chapter, the relationship that was put forth is that A affects M and A affects D, and that M additionally affects D, so this outer triangle here. And I, in order to incorporate S, am saying that I think that S independently affects each of these things. Okay. In order to begin testing the soundness of this DAG, I need to find some things about it that I can test. And one of those things is implied conditional independencies, which we've already talked about. So I can use that command in the DAGity package, okay? And so I'm going to do that, and nothing pops up. And the reason is because there's no implied conditional independencies here. This is interesting because in order to have an implied conditional independency, there has to be something to condition on, a third variable, that reveals an independency between two otherwise related variables. But here, everything is connected by a single line. And so there's no third thing to condition on that could reveal an independency. So that's interesting. Does that mean that our DAG is somehow not is automatically incorrect? Well, no, it just means that we can't test it that way. But there might be reasons outside of the data, outside of the DAG, that makes you think that this is correct. Okay. Now, one thing that we could try to do to remedy the situation is we could use another variable. So if there was another variable that was either in our data set or that we could go out and collect that somehow related to these things, putting it into the DAG where it would belong could reveal or could make it so that new DAG would have some implied conditional independency. So let me give you an example. So let's say that there's an additional variable X that was a mediator between A and M here, okay? Well, that DAG would look like this. So here's X, and here are the implied conditional independencies that are now available to us if X was real. But I'm pushing forward, assuming that there is no variable akin to X. Okay, so I'm going to make my regression, all right? So here I'm just getting my data together, standardizing the D, M, and A, and then I'm adding my S variable, which is just the South variable in the data set, in the waffle divorce data set. And so all I'm doing, so I have D divorce is a normal distribution like we've had in the past, and then I'm regressing on each of these terms, a BA, a BS, and a BM, right? And that will represent each of these direct effects from A, S, and M. Okay. Now when I run this, here's my posterior distribution. So there's a few interesting things here. So it certainly seems like age is driving down divorce after you account for everything else, and that Southerness is actually increasing divorce rate, something about Southerness. But it also seems that marriage maybe has no effect here. Okay, that marriage rate is not affecting divorce rate. That seems peculiar to me, and we'd have to dig in a little bit deeper as to what these variables really represented and how the data was collected. But nevertheless, this could suggest that our DAG is wrong, right? It could suggest that this arrow actually, that there is no causal effect here, right? Now, that's a possibility. I want to say that just going through and finding variables that don't have a compelling coefficient associated with them is not a great way of developing your DAG, okay? But this is not a crazy idea, and so we're going to push ahead with that idea, continuing to explore. And importantly, if you were to report this, you would report the initial DAG and then the modified DAG and so on. And there's philosophical reasons behind that I won't get into, but that's what you would do so that people understood the process and the other possibilities and so on and so forth. Okay. So I'm going to generate a new DAG here where I've omitted the M to D causation. And now I'm going to write another regression where I'm also trying to incorporate the S to M and the S to A, right? That's part of my DAG. And so if my DAG is appropriate, I should see some kind of compelling coefficient for S to A and S to M. Again, not always, and all of this is done with caveats and supposed expertise about how these variables relate, but nevertheless, let's try that. So I'm going to run this, and what you get is a major error. Now, you don't see it here, but I've done quite a bit of fiddling to get this to run, and I can't get it to run. It has something to do with the algorithm not converging. Now, I have determined through a bunch of trial and error that the error is here in this coefficient, and I've tried all sorts of different values and starting values, and they all fail. But there is something just about this segment right here which continues to fail, and specifically this term right here. So the beta S to M term, which would be this arrow right here. Okay, so that's unfortunate. One thing is it suggests possibly that within our data there is that the relationship between S and M is highly unstable in our data, possibly, which is not a good indicator that S definitely has an effect on M. I mean, just the error itself may be telling us things, but it's not enough to really conclude anything about. Okay, so we're going to come back to that in a second, but because this larger model failed, we also don't get an estimate for the S to A. Okay, and so I'm going to run that in its own separate regression here. Well, I've already done it. Okay, and this model runs just fine, and what I get is it seems to be a pretty reliably negative relationship. So it does seem that there is a relationship between being Southerness and the median age of marriage. So perhaps something in the culture there tends to have people marrying earlier, just by the culture of the South, whatever those features are. Okay. So that seems to be real. Okay, but we still have to come back to this other relationship here that is still inconclusive, right? So we still have to try to think about this relationship, the S to M relationship. So it would have been very nice if that initial model or even the submodel would have ran, but they don't. But that's okay. So there's some other ways that we can go about trying to explicate that possible relationship or examine if it's real. And so we should be able to plot it, and we should be able to see a relationship. We should, in the data, given my DAG, I should see a correlation between Southerness and M. Okay. Now this correlation is, you know, I'm going to pause this and fix this code real quick. Okay, I'm back. So I was going to say that we should be able to see some kind of correlation between Southerness and M. Now this is a little bit weird because it's not the perfect test, because Southerness is a binary variable, right? It's not a continuous variable, and usually the typical Pearson correlation coefficient requires two continuous variables, but S is not. And so I'm using a rank-based, which still has its own problems here with this, but that's okay. It's just an indicator, okay? And so we see some kind of possible correlation between the two, but it's not, well, anyway, so there's some indication. But we should also be able to apply a non-Bayesian model, okay, for M based on S, A and S, okay, as well as a non-Bayesian linear model just including S as a predictor of M, okay. Now, when I run these, I'll just run them both and we'll look at the outputs. I see that the effect of S, or the apparent effect of S on M, is non-existent, okay? So we can see that in a few ways. So we do get a value for the apparent relationship, but notice the standard error. The standard error is as big as our estimate for the relationship between S and M, right? Which suggests a very high p-value, which is what we have here as well as here, okay? And that suggests that there might not be a relationship then between S and M, okay? So again, here we see here's our estimate, but in this case, the standard error of that estimate is larger than the estimate. So in other words, the estimate is definitely crossing zero, or so 0 is a very plausible value for the relationship between S and M. Okay. So it suggests then that there is no relationship. So all of this does suggest that there is a relationship between A and M, but not between S and M. And so that would reveal a different DAG. Let me give me a second here. Okay. So anyway, all of those outputs would suggest a DAG where, well, I'll just put it up here, right? Where A is affecting M, right? And so we've seen that. Where have we seen that? We have seen that. Okay, yeah. So we've seen that here in this linear model, okay, where A is probably affecting M, okay, where A is affecting D, okay, and we saw that in the very first regression. Where are we at here? No. Okay, we saw that here, right? And let's see what else. Where S is affecting D, we saw that in also again in that initial regression, and that S is affecting A, and again we saw that in in the segment analysis, or whatever that I called it, just taking that chunk of the larger model that failed. Okay, so again, what I have shown here is one way to go about it, based on some assumptions about how these models might relate, and then began to whittle things down according to the data. And each one of those decisions was based largely on conjecture, and does not necessarily mean that it's true, okay? And all of these decisions in real life would have to be backed up with some kind of expert knowledge or some knowledge about how these variables actually behave in the real world, and not just in your data sample, as well as how the data was collected, and possible incorrect inferences you're making based on the specifics of how the data was collected, etc. Okay, and then last thing, again, as if you were to report this, you would definitely want to report the process that you went through and all of the different models. And again, there's philosophical reasons for that I will probably make a video on. But anyway, that's it. Thanks.